Hello, good day to all my Form 4 students. Today we are here to continue on the chapter rate of reaction, and we are going to do part 5 of this chapter. And the two subtopics that I am going to discuss for today is on application of factors that affect the rate of reaction. The factors that affect the rate of reaction teacher have discussed in part 3 and part 4 of our video on this chapter. All the four factors affecting the rate of reaction teacher have discussed in part 3 and part 4. And today the teacher also going to introduce on collision theory. Okay, so please remember collision theory comes out a lot for essay question. So you must know what is collision theory. Only then we can look at how does collision theory is involved or can be related with the factors that affect the rate of reaction. Okay, so let's start. So let's go to the application of factors that affect the rate of reaction. So as teacher had told you in part 3 and part 4 of our video, teacher discussed all the four factors, which is size of the reactant, temperature, concentration and catalyst. So these are the four factors that affect the rate of reaction. Now let's look at how does the first factor, which is size of reactant. So please remember, when teacher says size of reactant, it must be solid. At least one of the reactant must be solid in order for you to manipulate this factor. Now, how do you apply size when it comes to this condition, which is not to say condition but your everyday life? Okay, so now charcoal is cut into smaller pieces. Okay, charcoal is cut into smaller pieces. Just imagine if charcoal is cut into bigger size versus smaller size. Okay, versus smaller size. So you can see charcoal which cut into bigger size, the reactant has only small surface area to react. But when you have smaller cut charcoal pieces, what happens is the reactant has more total surface to react. Of course, when you compare the size of reactant, of course the size of reactant here is big. That means the surface area of this reactant, this charcoal is big, this piece is big, and these pieces are smaller. But when you combine all the total surface area, mark my word, when you combine the total surface area, you can find that this piece, smaller cut piece, have larger total or bigger total surface area. So more reactant can react on it. So that is the reason why charcoal which has been cut into smaller pieces is easier to burn compared to charcoal which has been cut into bigger pieces. The same goes to cooking in smaller pieces. For instance, when you're cooking chicken, for instance, when you put a large whole chicken, might take a longer time. Okay, will take a longer time compared to smaller cut pieces. Why? Because large piece of chicken has, even though surface area is large, but the total surface area compared to the smaller cut pieces is smaller. So the reactant will take a long time to react towards upon the chicken, larger chicken, piece of chicken compared to smaller cut piece of chicken. So this is how size of the reactant plays a part in your everyday life. Now let's go to number 2, temperature. Okay, so we know that temperature, higher the temperature, higher the kinetic energy. So when the kinetic energy increases, rate of reaction also increases. Now let's go to how do we apply, how can we apply temperature in our everyday life. Now see, when you add food inside refrigerator, that means you are not killing the microorganism. Okay, you are just slowing down the process of the microorganism so that the food will stay fresh a bit longer. Okay, does not guarantee that food does not go bad at all. Okay, but the food can go bad or go stale, or the vegetable might get rotten, but it might prolong the storage uh, life. Okay. Now, so let's go to cooking in pressure cooker. When you cook a food in pressure cooker, what happens is the pressure together with the temperature, of course, will help the food to cook faster. When you cook the food in a usual stove, compared to pressure cooker, if you stove, it takes maybe 10 minutes. In pressure cooker, it might take 3 minutes. Why? Combination of pressure together with temperature. Okay, higher the temperature, higher the rate of reaction. So the food, of course, will cook faster in pressure cooker compared to other stove or usual appliances. Alright, now let's go to concentration. So how am I going to explain concentration is true. How do concentration of a sulfur dioxide, a gas called sulfur dioxide in industrial areas. The concentration of gas called sulfur dioxide in industrial areas is very high compared to rural areas. So what happens is this sulfur dioxide, again we go to acid rain. When this sulfur dioxide gas gets diluted in rain, it will produce acid rain. And the best part is the concentration of the acid rain is very high. So this concentration will eventually corrode the buildings. Okay, it will damage and corrode the buildings faster compared to other rural areas. Why? Thanks to the concentration of sulfur dioxide. Okay, why? Because the sulfur dioxide has higher concentration. Okay, higher concentration, and when it gets diluted during rain, it will produce high concentrated sulfuric acid. So when the sulfuric acid is concentrated, it is more than enough to damage the building. So another explanation on concentration, how does concentration affect the rate of reaction is any seafront iron structures, a building or any structures which is kept near sea. Okay, seaside, it might corrode or rust faster. Why? Because the concentration of dissolved salt is higher. Sea breeze contains high amount or high concentrated of dissolved salt. Okay, concentration of dissolved salt. So when it has higher concentration of dissolved salt near the seafront or the sea breeze will make the iron structure rust faster compared to the same iron structure which has been kept elsewhere. So this is how the concentration of substance plays a part for a certain reaction. Okay, now let's go to the last one, which is catalyst. So as we know, catalyst increases rate of reaction. So teacher have explained to you how catalyst increases rate of reaction. So here catalyst, I can give you 3 examples of how does catalyst is used. Okay, so first is Haber process. Haber process is the production of ammonia. Okay, it uses catalyst, iron as catalyst. Contact process is actually production of sulfuric acid. Okay, on the second stage, where from sodium dioxide is being converted into sulfur dioxide being converted into sulfur trioxide. Okay, sulfur dioxide we converted into sulfur trioxide. We use a catalyst called vanadium 5 oxide. Okay, which helps the rate of reaction faster. Now the third example for the usage of catalyst is Ostwald process, where platinum is used. Ostwald process is to produce nitric acid industrially. Okay, so nitric acid industrially, where we use platinum. Okay, we use platinum as the catalyst to produce rate of reaction. Now let's continue on collision theory. Now please remember, collision theory is very important, especially when it comes to essay question. Okay, now when teacher explained collision theory, I hope you can understand better regarding the 4 factors affecting the rate of reaction. Why? Because the factors affecting the rate of reaction has very much connection with the collision theory. Now let's go to first question. What happens during reaction? So when two particles collide, for instance, teacher have beaker A containing substance A, beaker B containing substance B. Just say teacher want these two to react. Of course, I have to mix them, correct or not? So you just can't leave A and B in their respective beaker and expect them to react. No, it won't happen. So you have to eventually mix them. So that's how the reaction happen. So in order for reaction to happen, two things have to go through, the substances or the reactants has to go through two process, which is breaking bond, breaking of bond, and forming bond. Okay, now in order to break the bond and in order to form the bond, very important. Why am I asking you this question when explaining collision theory is like what I explained, A has to be mixed into B. Okay, A has to be mixed into B for it to react. So what happens is when A mixes with B, they will go through collision. Okay, they will go through collision. So when they go through collision, two things happens, which is they either break the bond or they will form the bond. They must break the bond. Please remember that they must break the bond in order to form a bond. Okay, so that is the reason why in order for two things happen, they must collide. Okay, now so that is what we call by collision theory. So now what am I going to discuss is three important, okay, not to say factors, three important discussion regarding collision theory. So the first discussion is what is collision theory? Collision theory is says that chemical reaction that happens must have particles to collide. So this is what I mean by, remember just now teacher draw the beaker A and beaker B. So they must collide. In order for them to collide, you must mix them. You must mix them. So that's why you have to make sure the particles connect or react with each other, collide with each other. And in order for the chemical reaction to happen, you must have kinetic energy. So the chemicals or the substances or the particles must have enough kinetic energy. This shows that means when the particles are colliding, they already have certain kinetic energy. So this kinetic energy will be helpful in order to produce reaction. Now let's go to what is effective collision. Okay, so another thing that you need to know is kinetic energy. What is needed during chemical reaction is activation energy. Okay, so activation energy. So activation energy is the, I have to explain to you what is the meaning of activation energy. Activation energy is the minimum amount of energy needed by reactants to react and produce reaction. Okay, so again, so in order for chemical reaction to happen, we must involve a term called activation energy. Now, what is the meaning of activation energy? Remember, teacher explained to you how B has to be mixed with A in order to produce a product. So the same goes. Activation energy, these are the example of graphs for activation energy. Okay, so don't worry about this one. Okay, teacher just explained the shape of the graph and how activation energy is detected for each of the reactant. Okay, now, so you can see that, okay, so you can see that activation energy is, now see, minimum amount of energy needed by reactants. This shows that the activation energy, it comes from the reactant. Please remember that the activation energy comes from the reactant, none from the product. Okay, so now, so this is how we identify activation energy, activation. Okay, why? Because we say that this is the minimum activation energy. Sometimes the particle can go beyond it, doesn't matter. So that is the amount of activation energy needed in order to particles to produce a reaction. Now let's go to this graph. A bit different, right? So this is what we call by exothermic and endothermic reaction, but please don't worry about that. We will see that in the coming chemistry chapters. Okay, now, so again, please remember activation energy starts from the reactant. Okay, so starts from the reactant. So this is what we call by activation energy. Alright, so please remember activation energy must start from the reactants. So that's how we identify the activation energy. Alright, okay, now so let's go to what is said to be, what is the effective collision. Okay, so effective collision is a collision which produces organic. Effective collision is collision amongst the particles or the reactants which can guarantee a reaction. Okay, so what are the effective collision is collision that guarantees or has or produce a reaction. Okay, so now see, so please remember, teacher was using the word the particles collide. Yes, the particles collide. They can collide, but not necessarily they can produce a reaction. So here we differentiate between particles colliding and we differentiate between particles effectively colliding. So particles colliding does not guarantee a reaction, but particles which are effectively colliding, okay, when particles are effectively colliding, they will definitely guarantee a reaction. So that is the reason why when you are explaining regarding collision theory, please remember that effective collision is important. Okay, so effective collision is important when you are explaining regarding collision theory. Like how I said, activation energy is important when you are explaining collision theory. Now, effective collision is important when you are explaining collision theory also. Now, let's go to now. You might be wondering, teacher was talking about how effective collision guarantees a reaction. Now, what are the two important factors or conditions that makes the reaction to happen? Okay. Now, or what are the two conditions for the particles to collide effectively? Teacher repeat. What are the two conditions for the particles to collide effectively? So, first is what we call by enough activation energy, minimum or more. That means the particles must have just minimum enough activation energy or they can have more activation energy, doesn't matter. So this will guarantee effective collision. Now let's go to correct orientation. Now what do we mean by correct orientation? So please remember the particles, they will collide like this. Okay, they can just collide without any reaction. But there will come one moment where they will collide with correct orientation. This is what we call by correct orientation. For instance, imagine jigsaw puzzle. Okay, the jigsaw puzzle can have places to fit other puzzles, left, right, center. Okay, left and the left and right and top and bottom. Okay, jigsaw puzzle, it might have like this. Okay, place to fit left, right, bottom, doesn't matter. But the other jigsaw puzzle that is going to be connected with it must be correctly orientated, correct or not? With correct size. So this is what teacher mean by correct orientation. Meaning, so they must be in a correct orientation to produce collision. During collision, okay, so important is during collision. During collision, they must collide with correct orientation. So that guarantee. So again, let me connect all this collision theory. Okay, so first collision theory, first thing you must know, in order for particles to produce when they are colliding, Okay, when the particles are collide, that means when you mix A and B, what happens? Two things happens, which is the particles will break the bond and the particles might form a bond, new bond, break the old bond and form a new bond. Now, second is collision theory talks about particles that must collide. And that's why we need to mix the reactant. They will have a kinetic energy because the moment something is moving, they have kinetic energy already. So they have kinetic energy and they must have activation energy. That means activation energy energy, they will have enough activation energy to produce reaction. And in order to produce guarantee a proper reaction, they must go through effective collision. Effective collision has two conditions, which is they must have minimum or more activation energy and the collision must be in correct orientation. So that will produce reaction. So this is what you need to know regarding collision theory. Okay, so teacher will see you in our next video explaining and connecting all the four factors that affect the rate of reaction with collision theory. Okay, so I hope you can understand the teacher's video of today. Thank you for watching. See you all.